bar.
All right. Any questions on the homework, guys?
So many. Can I start with question number?
Oh wait, I had a question.
My computer won't.
I don't remember what
17.
What?
17, I agree.
I literally did 17.
I mean,
Wow.
you
I already did 17.
Wait, there's no way you did it right.
I kept getting 0.
I screwed up. I was saying
It could be 0.
Mr. Florio.
I need 13.
I don't know. We'll find out in a sec.
I need 27, 29. I also need 30.
Oh, 33? 33 and 47.
Just all of them.
All right. So
I have a question.
for 27 to 38, I'll do like 2 of them.
Okay. Wait,
Yo, what?
you said 27 and 38?
My computer won't even show me a screen.
Okay. I'm okay with that.
Like in that section, I'll do 2 of those. And then 17, you said? And then
I just have a black screen with no buttons.
Thank you.
But there's a mouse. And I've been on this for
It's
a
every day.
long time.
Every day.
It's not my fault. I know.
I'll donate my tablet too because I don't use it that much. If you want me to donate that.
This seems like way too much math.
But if I ever need it,
Yeah, that's my phone at home.
Like what?
Why? Was it on purpose?
No. Bob just living life today.
Living like this.
Whoever texts me, oh well.
Oh my gosh, I'm gonna text you so much now.
She washed them and they came out
Alright, here we
so
go.
white.
Check
She was so happy about it. Then she's like, it looks like I got brand new sneakers.
all right. So number 17.
Yeah. No, I think so. Wait. Wait, will you look at this real quick?
I love how my mom's just sweet.
Yeah, it's okay.
I love me all the time. I have to
Okay.
Okay, well,
I can't take Advil. What? It's a blood thinner.
wait, really? Oh my god, it takes like 4 days.
All right. So number 17.
No, I'm not supposed to take
Wait, will you look at this and see if I did it right? Before you.
There's a lot going on right
That would take a lot.
It's not about you.
Let's follow along.
All right. So what we said last class is if you're looking for the area under the curve between -1 and 1, the way we did it at first was like make a bunch of rectangles and approximate it. And then we said if it was like a nice shape like a triangle, circle, rectangle, we can like draw the picture and find out the area of the geometric figure. But when you have something that isn't a nice function where you can draw the circle, triangle, square, and we don't want to take out a bunch of rectangles anymore. We want to get the exact area. The fundamental theorem of calculus told us a way that we can do that, and it relates this to the antiderivative stuff that we did at the beginning of the chapter. So in general, if I want to find the area under a curve between a and b of a function, we just have to find the antiderivative of that function, plug in the endpoints, and subtract them. So what we need to do when I'm given this problem is I need to find out what is the antiderivative. Once I find the antiderivative, plug in 1 and -1 and subtract them into the antiderivative. So first thing, I need to find the antiderivative of this, and I look at this function and I say I have the cube root of t. Let me just rewrite that as an exponent so I can use the power rule. So this is the same thing as t to the 1/3 minus 2. And now when I find the antiderivative, that's just when you add 1, right, to the exponent and then divide by that number. So what's 1/3 plus 1? So it's going to be t to the 4/3 over 4/3. And then the antiderivative of 2 is going to be 2t. And we're going to need to plug in 1 and -1 and subtract them. So this is like the notation. We're going from 1 to -1. So 4/3 divided by 4/3 is the same thing as multiplying by 3/4, right? So this is really just 3/4 t to the 4/3 minus 2t from -1 to 1. All I did is rewrite the dividing by 4/3 as times 3/4. All right. So what I'm going to do now is set this part up. I need to find the value of the endpoints and plug them in. So I'm going to plug in 1. So I'm going to plug in 1. This is like my f of b part. Minus, and I got to do the same thing and plug in -1. So it's going to be 3/4 times t to the 4/3 minus 2 times t. And now I'm plugging in -1, this number right here. Okay. So what we have here is, this is like your your antiderivative at B minus your antiderivative at A. Okay. So what do we get? Well, 1's an easy number to work with. 1 to the 4/3 is just 1. So this is going to be 3/4 times 1, which is 3/4 minus 2. -1 to the 4/3, is that going to be -1 or +1? -1 to the 4/3.
You can take that into, you can make that into two separate equations, kind of, can't you?
Well, all you need to do is look at the fraction. You would take the cube root of it and raise it to the 4th power. That's an even power, so it's going to end up being positive. So it's just going to be a +1.
So just based off of the top number?
Yeah.
What's my calculator doing?
Did you put the -1 in parentheses?
No.
Because your computer will read it as -1 to the 4/3. And 1 to the 4/3 is 1, and then it'll tack the negative on at the end. So it's going to be +1 times 3/4 is 3/4. -2 to no, -1 is going to be a +2. Now I'm going to distribute this sign here, so that minus is going to switch those signs on me. So let's see. How would you guys go from here? 3/4 minus 2? Let's just do this. 3/4 plus -3/4 is just 0, right? And then -2 plus -2 is -4.
So the answer is -4.
So it looks like I'm getting -4 here.
That's why it became 0, because it's negative.
Yeah, these parentheses right here, I can't stress enough. You don't always need them, but when you don't have them, when you do need them, you're in trouble. So it's better to have them and not need them than need them and not have them. So those parentheses, when you do like the f of b minus f of a, is going to be really, really helpful. So I'm going to pull this up for a quick second. This is just the answer. Are there any questions that people just want to have checked to see if they're right? Because I know, Tally, you were just looking for if you had it right or not, right?
I'm almost right, so.
Yeah, I'll do one of those ones too. I just wanted to pull this up. I'll go do that first. But we just did 17. Yeah, so 17 ended up being -4. But I'll come back and we can check some after. You said 20 what? 27 or 29?
Both, either one, or both.
So let's do the first one. So we need to find the antiderivative of this function. The antiderivative of 1 is going to be 1x. And the antiderivative sign is negative cosine. How do I know it's negative cosine, not positive cosine? The derivative of sine is cosine, so the antiderivative of sine is going to be negative cosine. You could go back to our chart, right? We can go back to that chart here. The antiderivative of sine is negative cosine. Oh, that's not what I want. There we go. All right, so, and that's going from 0 to pi. So if I plug in pi, I'm going to get pi minus cosine of pi. Minus, I plug in 0, so it's going to be 0 minus cosine of 0. Again, this is f of b minus f of a. So what am I going to get here? So this is going to be, what's cosine of pi?
1, -1.
-1, right? So pi minus -1. minus, what's cosine of 0? Cosine of 0 is positive 1. So it's going to be minus positive 1. So let's see, this is really pi plus 1. And this double, this is going to really be plus another 1. So it's going to be pi plus 2. So for secant squared, it's going to be the same idea. What's the antiderivative of secant squared? Isn't that just tangent? If you look in like the chart, the antiderivative of secant squared is tangent. So it's just going to be tangent x, and then you're going to plug in pi over 6 and negative pi over 6 and subtract them. So it's going to be tangent of pi over 6 minus tangent of negative pi over 6, whatever that ends up being. Other question. So these ones like secant tangent. Just look that up in your look that up in the antiderivative thing. The antiderivative, by the way, of 1 over x is natural log of x. So natural log showed up in this one. Do you want to see that one?
Are we supposed to be able to just recognize that?
Yeah.
Oh, okay.
Wait,
That's
can you move it to
interesting.
the side a little bit, really briefly?
Because
Remember we were talking about things that's actually.
So the antiderivative of 2x is 2x squared over 2, which is just x squared. And the antiderivative of 1 over x is natural log of x from 1 to e. So I need to plug in e. And then I need to subtract that when I plug in 1. So again, this is f of b minus f of a. So e squared, I'm just going to leave it as e squared. What's the natural log of e? I think it's just 1, right? Those are just inverse functions. I mean, you could just put in your calculator if you need to. Minus 1 minus the natural log of 1. I think that's 0. You can check it in the calculator, just to ln of 1. So this is going to be e minus 1, which is e squared minus 2. Stuff like this. I mean, if you never work with natural logs, which I don't know why you would, just put in your calculator if you're not sure. But I know these are inverse operations, so they just cancel out, which means it's either going to turn into 1 or 0. And natural log of 1, this really says, in my mind, I'm asking myself, the base is e. E to what power equals 1? Well, anything to the 0 power is 1. So anytime you have a log and the inside the argument is 1, it's just 0. Which one was the next question? 23. Oh, this one I think we should graph before we jump into it, but yes. Okay. What does that graph look like? And there's a reason why I want to graph it, because of the absolute value thing. So let's see if we can figure it out together. So
It's absolute value.
it is.
Oh, so it's gonna look like a B. That's how it's gonna be.
Did we go backwards?
Yes.
Okay.
So if I were to graph just 2x minus 5, it'd have a slope of 2, right? And so let me just plug in 5. So when x is 5, what's 2 times 5 minus 5? 2 times 5 is 10, minus 5 is 5. So it looks something like this, right? The absolute value part, what it's going to do is it's going to take this part here and just flip it up to make it positive, so there's no negative values. So at what point does it cross the x-axis? At what point is this thing equal to 0?
Oh, equal to 0.
At 2.5? So this function, I'm going to break up into two pieces because from 2.5 to 5, it's just 2x minus 5. But from 0 to 2.5, so this interval right here, the equation is going to be negative 2x minus 5, and we'll have to distribute. So I want to find this area first, and then that area. So the left area, I'm going to go from 0 to 2.5. And it's going to be negative 2x minus 5. And then if I want this area right here, then I'm going to go from 2.5 to 5. And it's going to be positive 2x minus 5. I would distribute this real quick. That's going to make it a negative 2x and a positive 5. So we find the antiderivative, negative 2x. The antiderivative of that is going to be negative 2x squared over 2. The 2's are going to cancel out, so it's just negative x squared. The antiderivative of 5 is 5x, and that's going from 0 to 2.5. Separately, this piece over here, the antiderivative of that's going to be positive x squared minus 5x from 2.5 to 5. So both of these, I need to do the fundamental theorem of calculus. I need to do f of b minus f of a. And then f of b minus f of a for the other one. So if I plug in 2.5, that's going to be negative 2.5 squared plus 5 times 2.5. If I plug in 0, that's going to be negative 0 squared plus 5 times 0. This guy over here, now my upper limit's 5, so I got to plug in 5. And my lower limit's 2.5, so then I got to plug in 2.5. And then put it in the calculator and see what you get. I'm not going to do that part.
If I have a question.
Yes.
So I understand the whole fundamental theory of calculus.
Yep.
Can you go off a little bit?
Yes.
So from here down, I understand like what you did, but the fact that you got that like
Having to split it up, right?
yeah, that's the part that I was
Yeah. So we did one absolute value in class where we saw it. And then it was just the absolute value of x, so it was like looking like this. So we went from, I think it was like -1 to 0 and 0 to 1 instead of doing it from -1 to 1 because this thing changes once you hit the x-axis. It's one of those questions where like, if we do it a lot, you'll get the hang of it.
Okay.
If you don't do it a lot, then it's just kind of like, oh, okay, now I see it. But like not something that you or I would have thought of if it was just us by ourselves.
Should you just take half of? Actually, that doesn't work.
It happened to be half of the interval, but
It did not work like that.
the only reason why it was 2.5 is because I just solved for when this thing equals 0, because that's when it hits the x-axis, it kind of like flips up because it's got to stay positive.
What did you get for an answer?
What number is this one?
23.
25 half, so like 12.5. Other questions on the homework?
Yes. 41 or 3.
Yeah, which one? Why don't I set both of them up? And then maybe start both of them, but not get to like the adding, subtracting stuff at the end?
Yeah.
So I want to find the area under this curve. So we have defined that as the definite integral from 0 to pi over 2. That's the interval of my function. My function happens to be cosine of x. So the area under the curve is equal to that value. Now, what is the antiderivative of cosine? Positive sign. The derivative of cosine is negative sign. The antiderivative is positive. From 0 to pi over 2. So it's going to be sine of pi over 2 minus sine of 0. So sine of pi over 2 is 1 and sine of 0 is 0. So 1 minus 0 is 1. So the area under that curve is exactly 1. Sorry, I sped up, didn't I? So the area under the curve is just the antiderivative of this function from the two endpoints. And then I just found the antiderivative of cosine with sine, plug in my two endpoints, and subtract them. And then I'll just talk about number 43 quickly. I won't go through the whole thing, but I'll go through the setup. This says find the area of the region bounded by this, x equals 0, x equals 2, and y equals 0. So 5x squared plus 2, you don't need to know what it looks like. But 5x squared is going to look something like this. And I want to find the area between x equals 0, x equals 2, so x equals 0, x equals 2, and y equals 0. So that's this region right here. What's the area here? And that's just an area under the curve. So the area is going to be the definite integral from 0 to 2 of my function 5x squared plus 2. So find the antiderivative, plug in 2 and 0, and subtract them. 5x cubed over 3, 5x cubed over 3 plus 2x from 2 to 0. All right, what do we think? Okay, so maybe we should do some more practice before we move on. All right, just because you asked for it, what I want you guys to do is go into the classwork part, and there's some definite integral practice. There's 8 questions. I want you guys working on this for the next, well, about 20 minutes or so. I want to make sure I give you guys the notes for the next stuff.
Well, how about we just do the classwork today and then no
But then what will you do for homework? You'll have nothing to do.
Nothing. We just don't.
Sometimes
do
we
it.
kind of need to do that.
I have to study for an ECE test, so maybe we just don't chill on this for a little bit.
Wait, where is it?
Go under classwork.
Do you want to be recording all of this?
So my thought is I'll just stop the recording now and then I'll re-record when we get to the notes. All right. So, have I been recording it? Oh, stop.